Today our lesson 12.2 is talking about matrix multiplication. In this lesson, we will learn how can we multiply matrices. And there are two types of matrices, a scalar multiplication and the matrix multiplication. But before talking about the matrix multiplication, let's see what is the scalar multiplication. Look at this matrix here. We have a 3 multiplied by this matrix. This real number factor, like number 3, we call it a scalar. And this number, such as it multiplied by each element in this matrix, we call this type of multiplication a scalar multiplication. So, if you want to multiply a matrix, like this matrix here, A11, A sub 1, 2, A sub 1, 3, by a scalar C, you have to multiply C by each element, like C times A11, C times A12, C times A13, and so on. This type of multiplication, we called it scalar multiplication. Let's have this example here. If you have this matrix A, which is 3, 2, 1, minus 1, 7, 4 as an example. This is our matrix. And C, the scalar number is 5. Find C times A. Here you have to multiply 5 by the matrix A. What you have to do? You have now to multiply this number 5 by the first element 3, where 5 times 3 is 15. Then, this number 5, you have to multiply it now with number 2. Then you say 5 times 2 is 10. Then you multiply 5 by the third element in this matrix, which is number 1, whereas 5 times 1 is 5. And then you multiply 5 by this one here, whereas 5 times negative 1 is negative 5. And then you multiply 5 by this 7 here, which is 35. And then 5 times 4, which is 20. This is our new matrix by multiply a scalar C times the matrix. This is the first type of multiplication. Let's solve now this problem here. In this problem here, we have a matrix A, a matrix B, and you have to find 4A plus 3B. So you have to multiply 4 times the matrix A, then you have to multiply 3 times the matrix B, then you have to add them. So 4A, that's mean 4 times 2, 8. 4 times 8 is 32. 4 times negative 3 is negative 12. 4 times negative 1 is negative 4. 4 times 5 is 20. And 4 times 2 is 8. Then 3b, which is 3 times negative 1 is negative 3. 3 times 0, 0. 3 times 5, 15. 3 times 0, 0. 3 times 3 is 9. And 3 times negative 2 is negative 6. Is it clear? What is the scalar multiplication?
Yes.
Okay. Now, they asked me to find 4a plus 3b. So what do you have? Now you have to add this matrix, which is this one, plus this matrix here. You have now to add them. And our new matrix will be 8 plus negative 3 is 5. 32 plus 0 is 32. Negative 12 plus 15 is 3. Negative 4 plus 0, negative 4. 20 plus 9, 29. And 8 plus negative 6 is 2. This is our new matrix. Is it clear?
Yes. Yeah.
Okay. So let's talk about some properties of the scalar multiplication. If there are matrix A and matrix B, and if its dimension is m times n, and here we have an matrix A 3 times 2, or sorry, m times n. Its dimension here is m times n, and there's a matrix B. Its dimension also is m times n. And C and D are scalars, are numbers that are multiplied. And O is the m times n zero matrix. And there's an O which we called it zero matrix. You then C times matrix A, if you multiplied a scalar number times the matrix A, you must get to the same dimension. If you multiplied C times D, if you multiply, like C is 4, D is 5. If you multiplied 4 times 5, which is 20, then you multiply it by matrix A, you must get the same answer if you multiply D only by scalar D by matrix A, then the answer multiplied by C. The third one, this one we call it associative property. The third one, if you add A plus B, the two matrices A plus B, then the answer multiplied by C, you must get the same answer if you multiply the scalar matrix C by element A, then the scalar matrix C by matrix B, then you add them, which is the distributive property. It's like a numbers. And also, if you add C plus D, the two numbers C and D, if you add them, multiply it by the matrix A, you must get the same answer if you multiply C by A, then add it to D by A, like the distributive property. And if you multiply 1 by any matrix, you must get the same matrix, which is we call it the identity property of multiplication. And if you multiply any matrix with 0, you must get 0, which is the property of 0. Is it clear?
Yes.
Yes.
Okay.
Yes.
Now, in this problem here, we will learn how can we solve a matrix equation with a scalar. But before that, if you have a 2y plus 3 times 5 equals 7, what you have to do first? If you have this type of equation, what you have to do first?
15.
You multiply 3 times 5. Okay, so the first step, you multiply 3 times 5, which is 15. Then after that, where's my variable? It is y. This 2y is added to 15. I want now to isolate a variable in a term and the other numbers in the second term. So since
Subtract
y is added to 15, since y is added to 15, I have now the opposite of addition is subtracting. So I have now subtract 15 from the two sides, from the left and from the hand. Then I will say after that 2y is equal -8 or equals -8. And after that, you multiply by half, or you divide by 2, you get the answer, which is -4. This is how can you solve any equation. And also the equation is in the matrix. In this problem here, we will see how can we solve the matrix equation with a scalar. Like this example here. 2x plus 3 times this matrix equal 8, 5, 11, 0. Like, what did I say before? 2x plus 3 times a number, give me a number. So the first step, I have to multiply this matrix 3 with this number or this scalar 3 by the matrix.
Teacher,
Yes.
you won't multiply also the 2x, like it won't be
No.
distributed property?
No. If it's like this, if it is like this, you will use the distributive property. If they give me a bracket. But see here, only 3 multiplied by this matrix.
Okay, teacher.
So let's multiply 3 now by each element here. Like, so it will be 2x plus 3 times 2 is 6. 3 times -1 is -3. 3 times 3 is 9. And 3 times 4 is 12. This is my new matrix. Equal 8, 5, 11, 0. Then after that, as we said before, I told you if you have 2x plus 3 times 5 equal 8. You told me I multiplied 3 times 5. Then I will isolate the variable and term and the numbers in other term. Here we have to do the same. We have to isolate a variable and a term and the matrices in the other term. How now? I will subtract this matrix from here and from here. So 2x is 8, this matrix 8, 5, 11, 0 minus 6, -3, 9, 12. Then let's do a subtraction. Let's now 8 minus 6 is 2, 5 minus -3 is 8, 11 minus 9 is 2, and 0 minus 12 is -12. Is this an x or 2x?
2x.
2x. I need x. So I have to divide by 2, or we can say multiply by half, since there's no matrix division. It's like multiply by half. If you multiply this side by half, you have to multiply now this matrix by half. So x is, let's multiply half now by this each element. Half times 2 is 1, half times 8 is 4, half times 2 is 1, and half times negative 12 is negative 6. That's it. Is it clear?
Teacher,
Yes,
Yes.
teacher.
if we have like the x is negative, are we going to make it like divide 1 divide by negative 1
Negative
for
x, you mean?
yeah.
Oh, yes. You have to divide by negative 1.
Okay.
Is it clear?
Yes, teacher.
Okay. Let's do this example now here. Another one. Here we have 3x minus 2 times this matrix equal this number, this matrix. The same steps. Let's say that it's 3x minus. Let's multiply 2 now by each element. 2 times negative 1 is negative 2. 2 times 5 is 10. 2 times 7 is 14. And 2 times 0 is 0. Equal positive 17, negative 13, negative 7, and 0. Then, after that, this 3x is, there's a matrix that is subtracted from 3x. And the opposite of subtraction, as we know, is an addition. So I have to add now this matrix to both sides. So by now, I will isolate a variable on a side and the matrices on other side. Yes?
Teacher, it's 10, not 5.
Where is it? Okay, 2 times 1 negative 2 here is 10. Thank you. So cancel each other. So after that, now I have an 3x equal 17, negative 13, negative 7, 0, plus negative 2, 5, 14, and 0. So 3x now is 17 minus 2, or 17 plus negative 2, 15. Negative 13 plus 5, negative 8. Negative 7 plus 14, which is 7. And 0 plus 0, 0. Now this is what? 3x. I need x. So what I have to multiply this both terms by what?
1 over 3.
Yeah, by the reciprocal of 3, which is 1 over 3. So x is 3rd times 15 is 5. 3rd times negative 8 is negative 8 over 3. 3rd times 7 is 7 over 3. And 3rd times 0 is 0. Is it clear?
Yes, teacher.
Yeah.
Now, let's talk about the matrix multiplication. Now, did you take it before?
I studied it alone. I think so.
I
Yes.
studied it.
All of these matrices with teacher Nassim last year.
No, we did not study matrix multiplication, but I studied this.
No, I mean by determinant 3. Did you take it before?
No, we did not.
Okay.
Not matrix multiplication.
So, okay. The product of two matrices in a matrix is the product of two matrices is a matrix. It's okay. To find an element in the product matrix, you have to multiply the first row with the first column. What does it mean? That means you have to multiply the first element with the first element in the column, plus the second element with the second element in the column. This one, and this one with this one. A sub 1 times B sub 1 plus A sub 1 2 times B sub 2 1. The first row with the first column. Then, after that, after I finish, I will multiply the first row, but now with the second column. That's I multiply the first element with the first element in this column and the second element with the second element in this column. The second element in the row with the second element in the column, like A11 times B12 plus A sub 12 times B sub 22. Then after that, after I finish with the first row, I will go now to the second row. Then I will multiply it with the first column. That I say the first one, which is A sub 21 with B sub 11 plus A sub 22 with B sub 21. After I finish the first row, I will multiply the first row now, the second row, sorry, with the second column. A sub 21 with B sub 12 and A sub 22 with B sub 22. That's it. So don't forget, row by column, not column by row, row by column, row by column. So row. So you will see row by column, row by the second column, then row by column, row by the second column. Then you added them like this, each to one. You added them. After you added them, you get a new matrix that have the same dimension. Or not the same. I will tell you how can we find the new dimension for the matrix. Because in addition, if you add 2 by 2,
we will always have the same dimensions in addition, but we're going to use resultant matrix for multiplication.
Yeah, when you have 2 by 2 here and 2 by 2 here, in addition, you must get 2 by 2. But in multiplication, no. In multiplication, later on I will tell you about it. If you have like this matrix here, its dimension is 1 times 3. And if I multiply it by a new matrix, which dimension is 3 times 5, okay, here look at them. They can, and it's okay. We can multiply two matrices with different dimension, but we must have the number of columns in the first matrix equal the number of rows in the second matrix. If they are equal, like you can say that they are canceling each other. So our new matrix, or its dimension is 1 times 5. Later on, I will tell you about it. So here, that's just, I want to tell you that, like in addition and subtraction, if you add two matrices, we must get the same matrix with the same dimension. Here, no, there's not any two matrices. I can multiply them, and if I multiply them, there's a new matrix. I will get it. It's have a different dimension than the basic matrix. But as we said here, the product of two matrices is a matrix. Later on, I will explain for you how can we find the new dimension for the matrix, which I said here before. Now let's have an example of how can we multiply matrices. If matrix A is 2, 1, negative 3, 0, and matrix B is negative 1, 3, 0, 4. Multiply the element in the first row of A by the elements in the first row of B, in the first column of B. What does it mean? That means I have to multiply this by this. Then 2 times negative 1. Look here, 2 times negative 1 plus 1 times 0, which is equal negative 2. Then after I find this answer, I will replace it in the first one, which is A. So the new answer, which is A sub 1, 1, that means it comes from multiplying the first row with the first column. If I say now, if I want to write now A sub 1, 2, that means I multiply the first row with the second column. A sub 2, 1, that means I multiply the second row with the first column, so I will write it here. And A sub 2, 2, that's I multiplied the second row with the second column, and the new answer, I will write it here. So now, let's see here. Then, so multiply 2 times negative 1 plus 1 times 0. And the answer is negative 2. Then, I multiply the same row, but now with the second column. Like 2 times 3 plus 1 times 4. I'm sorry. 2 times 3 plus 1 times 4. And the answer, if you add them, is 10. I will write it here now. After I finish, I multiply now the second row, the first column. So negative 3 times negative 1 is 1, plus 0 times 0, 0. So the answer is 3. I will write it down. And then negative 3 times 3 is 9, plus 0 times 4 is 0. So the answer is negative 9. So my new matrix is negative 2, 10, 3, negative 9. Now I will solve an example here. If you have this matrix, and you have to multiply it by this one as an example. As I told you, the first row, the first column. So 3 times 5 is 15. Then 5 times -2 is -10. This is the first element. 3 times 5 plus 5 times -2. Then the same row, but now with the second column. So 3 times 4 is 12, plus 5 times 1 is 5. Then this row now with the first column, like -1 times 5, which is -5, plus 4 times -2, which is -8. Then -1 times 4, which is -4, plus 4 times 1 is 4. Now, after that, I just simplify it now. So, the answer is -15 plus -10 is 5. 12 plus 5 is 17. -5 plus -8 is -13. And -4 plus 4 is 0. And the new dimension here is 2 by 2. Is it clear?
Yes.
Teacher, what if we have 5, -2, and -3?
Where's 5 and where do you mean?
The second matrix, what
Okay.
if we have down the -2, 3? Like not the same dimensions.
Here you mean here you mean it's like this?
Yeah. Like
And
we have down in the -2, 3. But we don't have in the first matrix like a number behind or like with the 3 to multiply.
like this you mean?
Yeah.
This is one new matrix. Okay, here you can multiply them because this 2, the number of rows is equal the number of the number of columns equal the number of rows. So the new matrix here, its dimension is 2 by 3. Tomorrow, inshallah, when I will continue the multiplication, I will show you how can this new matrix come.
Okay, teacher, thank you.
That's here just I give you the basic that if you multiply square matrix by square matrix, which is 2 by 2 times 2 by 2, you will get 2 by 2.
Okay, teacher.
Okay. I will stop here today now. Tomorrow I will continue, I'll repeat with you